All right, problem 5. This problem has a square root in it, so the function type is a square root, sometimes just called a root. It will be specific square root. For the domain, we know that the part underneath the square root symbol has to be greater than or equal to 0. So to find the domain, I take what's underneath and say that that has to be greater than or equal to 0. And then I solve, add 2 to both sides. So my domain, x is going to be greater than or equal to 2. And if I use interval notation, that's the way that looks. If I do plug 2 in, so a little bit of the shotgun approach, if I plug 2 in, 2 minus 2 is 0 plus 4. So I get the 0.24. And then I can plug other values in. What I want to be careful of, I want to make sure that what I plug in here is a perfect square. So when I subtract 2 from it, I should get 0 or 1 or 4 or 9 or 16 and so on. If you're not sure about those, just pick values and you'll get some decimals, and that's okay. There's also a pattern with square roots. From this point, I can go up 1 over 3. So if I plugged 5 in, oh, I only went over 3. I'm sorry. I go up 1 over 1 first. So if I plugged 3 in, I would get the square root of 1, which is 1, plus 4 is 5. Then I go up 1 over 3. And if I had room, I could go up 1 over 5. I'm just barely run out of room. So there's what my square root graph looks like. So the range, the smallest y value I can have is 4, and it will go up from there all the way to positive infinity. This graph does not intersect the x-axis, and it does not intersect the y-axis. So no x or y intercepts. And this point right here is a minimum. And that's the square root function.